In this video, we're still going to be looking at some key features of rational functions, but this time instead of being given the graph, we're going to be given the function and have to, again, just pick out the key features of the rational function. So first of all, we should always take the rational function and factor the numerator and the denominator and see if any factors are common that we could divide out. So if we take a look at the numerator, the only thing that we can really do with that numerator is divide out the common factor of 6, negative 6. So if I factor out a negative 6, I'd be left with x minus 2. The denominator, we also have a common factor of 3 that we could divide out. And that would factor into 3 times x minus 4. So we could reduce these leading coefficients. However, that's the only thing that we could do. There's no factors that are common that would divide out in this expression. So if I did want to reduce the leading coefficients there, it would just be negative 6 divided by 3 is negative 2. So negative 2 times the numerator, and then this would just be 1. I don't have to write the 1, divided by x minus 4. So there's the simplified version, but there were no common factors that would form wholes. So there is no whole on this rational function. Okay, to find the x-intercepts, what we do is we set the numerator equal to 0. And you can use, in this case, either the unsimplified or the simplified. This GCF is not affecting the x-intercept because we just set any factor equal to 0 and solve for x. So it doesn't, again, matter if I use the numerator or the denominator. The factor that I'm looking at that I set equal to 0 is the x minus 2. So if I set that equal to 0 and solve, adding 2 to both sides, we get the x-intercept is located at 2. So that means the point 2, 0 is going to be the location of the x-intercept. To find the y-intercept, we substitute 0 in for x and then solve. So again, it doesn't matter if I use that numerator or the denominator function. I'm going to use the simplified version, but substituting 0 in for x would say negative 2 times 0 minus 2 divided by 0 minus 4. Okay, so 0 minus 2 is negative 2, so we're going to have negative 2 times negative 2 as the numerator, and then 0 minus 4 is negative 4. And so if we simplify this, we have negative 2 times negative 2 is positive 4 divided by negative 4. So that tells me that y equals negative 1. So my y-intercept is going to be located at the x value of 0 and the y value of negative 1. Okay, to find the vertical asymptotes, we set the denominator's factors equal to 0 and solve. Again, the 3 or the simplified version of 1 is not affecting the location of that vertical asymptote. So again, we just set the factor equal to 0. So x minus 4 equals 0 is the location of the vertical asymptotes. And if we solve this equation, adding 4 to both sides, we get x equals 4 is the line of the vertical asymptote. For the horizontal asymptotes, we evaluate the lead coefficients. So I'm going to go back up here to my original function. The lead coefficient of the numerator was negative 6. I'm sorry, the reason I am using the lead coefficients is because we evaluate the degree of the function. So in this case, the numerator, I skipped this when I didn't explain this a second ago. So the degree of the numerator would just be 1. The degree refers to the exponent, the highest exponent that's used. And so since we have negative 6x plus 12, the degree of the numerator would be 1. notice that the degree of the denominator is still 1, 3 times x to the first power minus 12. So 1 is the degree of the denominator. The reason we're using the lead coefficients is because when the degree of the numerator is equal to the degree of the denominator, we refer to those as P and Q. So the degree of P is equal to the degree of Q. We divide the lead coefficients. So that's why I was looking at the lead coefficients earlier. But we need to understand that we're first evaluating the degree of the function and how those degrees relate for the numerator and the denominator. Okay, so I am going to divide these lead coefficients to find the location of the horizontal asymptote. So the lead coefficient of the numerator is -6. There's a huge delay in my computer right now. Sorry about that. There we go. And we're dividing that by the lead coefficient of the denominator, which is 3. And that's going to tell me the location of the horizontal asymptote. I can reduce this, which, if you notice, will give me the reduced leading coefficient that we did earlier. So -2. -6 divided by 3 is -2. So that is the location of the horizontal asymptote. If I could find the mouse right now. There we go. -2. So y equals -2 is the location of the horizontal asymptote.